Alright, now on rectangles, we move on to rectangles and we have the main ideas. We want to recognize and apply properties of rectangles and also determine whether parallelograms are rectangles. If we look at the definition, it's very basic definition. Rectangle is a quadrilateral with four right angles. Okay? And it further says that since both pairs of opposite angles are congruent, it follows that it is a special type of parallelogram. Thus, a rectangle has all the properties of a parallelogram. In fact, later on, we're going to look at the Venn diagram for quadrilaterals and also the hierarchy of quadrilaterals, so we can see why, in fact, that we can say a rectangle is a parallelogram, or we can say a square is also a parallelogram. But that would be later on. The addition for this, other than the properties of parallelogram, is that the diagonals of a rectangle are also congruent, and that's this theorem right here. If I see a rectangle, then the diagonals will be congruent. And there you have AC is equal or congruent to BD, which are the diagonals. Right, in the next page we have the properties of the rectangles, which are the same thing like I had mentioned as the parallelogram. Opposite sides are congruent and parallel, like we saw in the previous theorems for parallelograms. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals, we saw in parallelograms that they bisect each other. And again, the addition here is going to be this right here. Not only do they bisect each other, but they're going to be congruent. Alright, and the last one here, again, definition of four angles of right angles. Let's go ahead and look at an example here. Quadrilateral RSTU is a rectangle. Alright, so I know I'm going to have to use the properties of that, but let's go ahead and label this. R to T is 6x plus 4. S to U is 7x minus 4. I recognize that these two right here are diagonals, and the properties of rectangles. Diagonals, remember, are congruent for rectangles. So as soon as I see that it's a rectangle, and I'm given diagonals, I immediately know that they're congruent. So based on this, I could say diagonal RT is congruent to diagonal SU. I substitute each one. RT, the expression is 6x plus 4 is equivalent to the expression for SU is 7x minus 4. Again, coming up with this relation is the tricky part. The only thing that you have to remember are the properties, and it's the properties that are going to tell you what equations to do. Okay, because if you're dealing with angles, sometimes they may be equal, sometimes they may be supplementary. So just be careful on setting up your equations. Let's just use our algebra skills to solve for x. Subtract 4, get rid of this plus 4. And some of you do it a different way, that's fine. If you want to start moving the x's and then the numbers, it's up to you how you want to solve it. Let's combine like terms. You're left with 6x is equivalent to 7x. Combine like terms, minus 8. Now I want the x's on one side, so I have to get rid of the 7x and minus 7x. Put whatever I do to one side, do it to the other side. Combine like terms, so this goes to 0. You're left with negative 8. Divide by negative 1. Divides out, so I'm left with x. Negative divided by negative is positive, so I'm left with x is equivalent to 8. Now the directions did indicate find x, but just make sure that you read the directions carefully, because in some cases they may be asking for more information. Let's add to this problem. Let's make this point E, and let's say I had asked you to find RE. Now we already found that x is equivalent to 8. Now make sure that you also remember the properties. Not only do the diagonals, not only are the diagonals congruent, but remember that the diagonals are going to bisect each other. So this piece right here, R to E, is going to be the same thing as R to T. I'm sorry, E to T, which is half of my diagonal. So first, I would find the whole diagonal, and I'm going to go ahead and substitute now x is equivalent to 8. RT was 6x plus 4. But now that I know that x is 8, I'm going to substitute that in here. And 48 plus 4 is 52. I know that RT is 52. And because in a rectangle, diagonals bisect each other, I know that RE is going to be 1/2 of one diagonal, which is RT, which is 1/2 of, if I substitute, now that I know RT is 52, it's going to be 26. Alright, and I know it didn't ask for that, but on your assignment you are going to see problems like this. So just make sure that you read the directions carefully. Alright, the last thing, if you look at the notes, is proving that parallelograms are rectangles. And if you look at the definition, it had said, if you see right angles, then we know it is a rectangle. But let's say I don't see right angles like you see in this picture, but you see, or they tell us that the diagonals AC and BD are congruent, then that's also sufficient enough to say that it's that the parallelogram is a rectangle. Okay, so just be careful with that. Later on, we're going to use these properties to prove that it is in fact a rectangle.